Matrices. A clothes dealer sold 3 shirts and 2 trousers for 840 shillings and 4 shirts and 5 trousers for 1,680 shillings. Form a matrix equation to represent the above information. Hence, find the cost of one shirt and the cost of one trouser. After forming the matrix, which you can easily see, you get the inverse of the matrix. Multiply the inverse of the matrix on both sides. We get one shirt costs 120 shillings and one trouser costs 240 shillings. A and B are matrices. If A is equals to 1, 2, 4, 3, find B, given that A squared is equals to A plus B. We shall multiply A by itself. To get A squared, we find A squared to be 9, 8, 16, 17. Now, subtract A from A squared, we get the value of B. B is 8, 6, 12, 14. Given that A is equals to 1, 2, 5, 3, B is equals to 3, 1, 5, negative 1, and C is equals to P, 0, 0, Q, and AB is equals to BC, determine the value of P. What we shall do, we shall multiply matrix A and B. After doing so, we multiply B and C. After doing so, we compare AB and BC because they should be similar. You can see the first part of the matrix AB is 18, which corresponds to 3P on matrix BC. The second is negative 2, corresponding to Q. The third item is 30, corresponding to 5P. The fourth item is 12, corresponding to negative Q. Now, since they are equal, you can see that 18 is equals to 3P, or 30 is equals to 5P, giving the value of P as 6. For a matrix A is given by A is equals to x0, 5y. A, determine A squared. You multiply the matrix by itself, so A squared is x squared 0, 5x plus 5y, y squared. Then part B, if A squared is equals to 1, 0, 0, 1, determine the possible pairs of x and y. Now if we get 1, 0, 0, 1 to be equal to A squared, you can clearly see that the possible values of x are when x is negative 1, y is 1, and when y is negative 1, x is 1. A matrix P is given by 4, 7, 5, 8. Find the inverse of P. You can clearly see how it is found. You first find determinant by multiplying the lead diagonal less the subsidiary diagonal, and then interchange the figures in the lead diagonal, and then give a negative to the figures in the subsidiary diagonal, then multiply all the figures by 1 and 1 and negative 1 of the determinant, and multiply all the figures negative 1 of the determinant. You get the inverse of P. Given that P is equals to 2, 3, 1, 2, and Q is equals to 2, negative 3, negative 1, 2, find the matrix product PQ. Hence, solve the simultaneous equation. Now, if you find the product of the matrix is 1. The matrix 1, when you multiply with any matrix, the matrix does not change, it remains the same. So the matrix is 1, 0, 0, 1. So it means that if we multiply this matrix with the simultaneous equation formed on both sides, we get the solution for the simultaneous equation, which gives us x is equals to 1 and y is equals to negative 1. Determine the inverse of t, which is 1, 2, 1, negative 1. Hence, find the coordinates to a point at which the two lines x plus 2y is equal to 7 and x minus y is equal to 1 intersect. The inverse of t is a third, 2/3, a third, and negative a third. Multiply that inverse by the two simultaneous equations, you get x to be 3 and y to be 2. That's where the two lines x plus 2y is equal to 7 and x minus y is equal to 1 intersect. Given the simultaneous equation 5x plus y is equal to 19, negative x plus 3y is equal to 9. Write the equation in the matrix form. You can see part A written in the matrix form 5, negative 1, 1, 3, xy is equals to 19, 9. Part B, find the distance of the point of intersection of line 5x plus y is equals to 19 and negative x plus 3 y is equals to 9 from point 11 and negative 2. I've sketched a diagram to show the points. We have points 3, 4, and we have the point 11 and negative 2. Now, if you go across the vertical axis, you see that we have 8 units. If you go along the horizontal axis, you see that we have 6 units. Now, our points form a hypotenuse to the units have just named, which means we can use the Pythagoras theorem to find the distance between 3, 4 and 11, negative 2. This is squaring 8, squaring 6, and getting the square root. We get that the distance is 10 units. Use matrix to solve the equations. First, we write the equations into matrix form. We find the determinant, then we find the inverse of the first matrix, then multiply the inverse on both sides of the equation, and we find x to be 3, y to be 2. Given that matrix A is equals to 2, 3, 3, 4, find A, the inverse of A. So A, negative 1, the inverse of A is found first by finding the determinant of the matrix A. This is gotten by multiplying the lead diagonal, that is 2 times 4 less the subsidiary diagonal, that is 3 times 3, and then taking 1 all over the determinant, which is -1, and multiplying and multiplying with all the factors of the matrix, having interchanged the lead diagonal to be 4 2 instead of 2 4, and the subsidiary diagonal as giving it negative, so that it is -3 instead of just 3 3. We get an inverse of -4 3 3 -2. This inverse matrix pre-multiplying by the equation I have been given helps us to find what x is. X is 2,000 shillings, y is 1,500 shillings. Find the inverse matrix 9876. The inverse is -3 4 7 over 2, -9 over 2. Two matrices A and B are such that A is equals to K4 3 2 and B is equals to 1 2 3 4. Given the determinant of AB is equals to 4, find the value of K. First we find AB by multiplying the two matrices, and then we find the determinant, and automatically after finding the determinant we simplify and find the value of K to be 5. Find the inverse of A of matrix A. You can clearly see how the inverse has been found and how the inverse can be used to solve the subsequent questions. The product of matrix 0 1 2p and -1.5 -0.5 p and p minus 2 is a singular matrix. Find the value of p. A singular matrix is a matrix where the determinant is 0, so the matrix should be multiplied and then the determinant is to be found, and automatically we find the value of p to be 3. Given that A is equals to 1 0 -2 3, B is equals to 3 0 2 1, and C is equals to 2ab minus a squared, determine C. Now C can be determined by multiplying 2ab, the square of A, and we get C to be 508 -3. A trader bought 2 cows and 9 goats for a total of 98,200 shillings. If he had bought 3 cows and 4 goats, he would have spent 2,200 shillings less. Form two equation to represent the information. Use the matrix method to determine the cost of a cow and that of a goat. The trader later sold the animals she bought, making a profit of 30% per cow and 40% per goat. 1. Calculate the total money she received. 2. Determine correct to 4 significant figures the percentage profit the trader made from the sale of the animals. Two shopkeepers, Juma and Wanjiku, bought some items from a wholesaler. Juma bought 18 loaves of bread 40 packets of milk and 5 bars of soap, while Wanjiku bought 15 loaves of bread, 30 packets of milk, and 6 bars of soap. The prices of a loaf of bread and a packet of milk and a bar of soap were 45 shillings, 50 shillings, and 150 shillings respectively. A represent 1. The number of items bought by Juma and Wanjiku using a 2 by 3 matrix. 2. The prices of items bought using a 3 by 1 matrix. B. Use the matrices in A above to determine the total expenditure incurred by each person and hence the difference in the expenditure. C. Juma and Wanjiku also bought rice and sugar. Juma bought 35 kilograms of rice and 23 kilograms of sugar and paid 8,160 shillings. Wanjiku bought 50 kilograms of rice and 32 kilograms of sugar and paid 11,340 shillings. Use the matrix method to determine the price of 1 kilogram of rice and 1 kilogram of sugar. Given that A is equals to 3x, x plus 1, 2, and B is equals to 1, 2, 3, 0, find values of x, for which AB is a singular matrix. Mambo bought 3 exercise books and 5 pens for a total of 165 shillings. If Mambo had bought 2 exercise books and 4 pens, he would have spent 45 shillings less. Taking X to represent the price of an exercise book and Y to represent the price of a pen. 1. Form 2 equations to represent the above information. 2. Use matrix method to find the price of an exercise book and that of a pen. 3. A teacher of a class of 36 students bought 2 exercise books and 1 pen for each student. Calculate the total amount of money the teacher paid for the books and pens. Given that A is equals to 2, 3, 4, 4, and B is equals to x1, 2, 3, and AB is a singular matrix, find the value of x. Given that matrix M is equals to 3p minus a half, p1 is a singular matrix, find the value of p. Kirai earned a basic salary of X shillings per month and Y shillings for each extra hour worked. Mutua basic salary is 20% more than Kirai's basic salary, but also earns Y shillings for each extra hour worked. In a certain month, Kirai worked 30 extra hours and a total of 70,000 shillings, while Mutua worked an extra 40 hours and earned a total of 88,000 shillings. 1. Form 2 equations in x and y to represent Kirai and Mutua's total earnings. 2. Use the matrix method to solve x and y. Elimu school bought 25 textbooks, 35 textbooks for 13,500 shillings from bookshop A. From the same bookshop, Soma School bought 21 textbooks and 38 exercise books and spent 1,300 shillings less than Elim School. Take X to represent the price of a textbook and Y to represent the price of an exercise book. A. Form 2 equation representing the above information. B. Use matrix method to determine the price of each item. C. In bookshop B, the cost of a textbook was 5% less and that of an exercise book was 5% more than in bookshop A. Kasuku School bought the same number of textbook and exercise books as Elimu School in bookshop B. Calculate the difference in the amount spent by Kasuku School and Elimu School. Given that A is equals to 2, 6, 2U, 5, and B is equals to 7, negative 3, U, 5, and BA is equals to 2, V, 16, W. Determine the values of U, V, and W. Given matrix P is equals to 4, 2, negative 7, negative 1, 2 is equals to negative 1, 5, 6, negative 3, and R is equals to 20, the inverse of P plus Q. Determine R.